Welcome to this brief tutorial on how to conduct a single sample t-test in SPSS and then write it up using professional conventions. The three goals of this is to show you how to enter data into SPSS, conduct the test in SPSS, and then how to use that data to interpret and present the results using APA conventions. Here's a scenario. Are elderly people's attitudes less favorable towards technology than the general population? A social psychologist assessed the attitudes of 11 elderly people using a scale where a lower score indicates a less positive attitude overall. The mean on this scale for the general population is 23.1, but the standard deviation is unknown. The data for the elderly participants are shown in the table to the left. Let's take a closer look at this data. We see that the sample size of the elderly is 11. The population mean is 23.1, but this population standard deviation is unknown. Now we don't have the sample mean, but we have all 11 data points, so we can figure that out. But since we don't have a population standard deviation, we cannot run a z-test. Therefore, we will be running a single sample t-test. Now, would we run a one or two-tailed test? If you answered one-tailed or directional, you are correct. They are asking if elderly people's attitudes are less favorable. That's a direction. So let's run a single sample t-test in SPSS. Go ahead and open SPSS and enter these 11 scores into the data file. Name the variable attitude and change the scale of measurement to scale. Stop this presentation until you have this completed. Your data in the data view will look like what you see on this slide. To conduct a one sample t-test, go to the menu bar Analyze, compare means and proportions, and select the one sample t-test. It will then produce a dialog box as shown in this slide. The first thing we will want to do is click on the left-hand box, click on your variable attitude, then click on the right arrow button between the boxes to move attitude to the box labeled Test Variable. Step number 2 is to click on the box labeled Test Value and edit its contents. The population mean for attitudes was 23.1, so that's what we will enter here. This is the null hypothesis value against which you are testing the sample mean. Also, make sure Estimate Effect Size is selected. Our third and final step is to click OK, and the analysis will run. The output is shown on the next slide. This is the output produced by SPSS. This is nearly everything we need to report our results in APA format. We need our sample mean, which is provided in the one sample statistics box. Our mean was 20.0. We will use an obtained t-statistic of -4.598, our degrees of freedom are 10, and our p-value of less than 0.001. Hey, this means it's significant, right? As long as it's below 0.05, it's significant. And we also have our effect size, Cohen's d. We'll use a point estimate of the 1.386. However, I want to show you here that the confidence interval is expressed as the difference between the means, and we want to report it in terms of attitude scores. So you can either hand calculate this or have SPSS conduct it or compute it for us. So we're going to just show you how SPSS will do it for us. Earlier in the course, we covered how to run descriptives going to the Frequencies tab. However, when we want to include the confidence interval, there's an easier way. Click on the Analyze tab, select Descriptive Statistics, and then go through Explore. Step 1. Move the variable to the dependent list. Step 2. Click on the Statistics tab. It will open a new dialog box. Select Descriptives so that the confidence interval is included as shown here. Click Continue. And then our final step 3 is to click OK. This is our SPSS output, and we can see our 95% confidence interval. And this does now show us that the lower and upper bounds are 18.50 and 21.50 if we round. Now we have everything we need to write APA results for a single or one sample t-test. A one sample t-test was conducted to evaluate whether elderly people's attitudes towards technology was less favorable than 23.1, the general population's mean attitude. The sample mean of 20.0 significantly differed from 23.1. T10 equals -4.598 with a p-value of less than 0.001 in one-tailed. Our effect size is 1.39 and the 95% confidence interval is 18.5 to 21.5. The null hypothesis is rejected, and it is concluded that elderly people's attitudes towards technology is less favorable than the general population. Let's just pretend that this is the output for our previous test. Note, I obviously replaced the numbers with fake data for illustrative purposes. And so now we see that the SIG column of our SPSS output reads 4.0. That's above our alpha value, which we always set at 0.05 in this class, so it is not significant. So we will be concluding there is no difference. Now we still want to report the effect size and confidence intervals. So this slide shows an example then of how to report statistical results if it is not significant. This concludes a brief tutorial on how to conduct a single sample t-test and write up the results using professional conventions.